A lot of people have gotten Ender 3s for free or really cheap on Marketplace. And a few people have wanted to convert it to print flexible material because you got to print slow anyway. So the high-speed printers of today is no different than printing on a slow printer like an Ender 3. But I highly recommend you convert from the Bowden tube to a direct drive. And there's a kit for like $35 to do that. And in fact, I have a Classic Filament Friday video from 6 years ago to show you how to do it. So let me show you that Classic Filament Friday video on today's episode.
In today's episode, I'm going to get rid of this PTFE tube and convert an Ender 3 from Bowden style to direct drive. I'll show you how to do it on today's Filament Friday. Filament Friday is brought to you every week by these Patreon supporters. Here's the direct drive unit that I'm going to install. I got this from banggood.com for free to do a review. It's on sale right now for $29.99, but when I opened the box, I was surprised. I was expecting a box of parts. This thing came fully assembled. Stepper motor, hot end, fans, bracket, wheels, and wiring all attached and labeled, ready to install, including tools to do it, plus tie straps and instructions. I was really pleasantly surprised by this. And pricing. $23 to buy the motor separately, or the hot end, like $12. Normally it's on sale for $8. Those two alone are more than this assembly, so it's really quite a good deal. I'm going to install this on my Ender 3 that had the dual gear drive. I showed that in a previous video. That dual gear drive is kind of worn out, so I'm going to replace it. So I took off all the tie straps, I unscrewed the Bowden tube, and then I loosened the belts and pulled those off the bracket. So then I can take this thing off and remove it from the machine. So what I had to do is put a wrench behind this wheel and then spin this wheel until it's loose enough that I could just take this bracket off. That was pretty easy. Now I need to disconnect the wire. Make sure the machine is turned off, and for safety's sake, just pull the plug before you work on any electronics. You access the electronics and the wiring through 3 screws, 2 in the front, and then there's 1 in the back. You have to move the bed to get to it. Once you have those 3, you can remove this plate. Now I did extend my fan wire here and I connected to direct power, but otherwise it's a normal stock setup. The first thing to disconnect is the thermistor from the front connector on the board, and then there's the filament cooling fan connector. Pull that out. Now I pulled it by the wires. You shouldn't do that, but my fat fingers couldn't get in there to just pull the connector, so be careful. The next thing to disconnect is the hot end wires. You just unscrew these 2 terminals and then pull the wires out. It's the 2 white ones on most machines, so just pull those out of the way. And then there's 2 screws at the back, and this is where the fan connects, the fan that cools the hot end. Now I've got mine spliced in with my cooling fan for the electronics, so it runs all the time. That's where you're going to see these 2 spliced together. Normally you would just see just the 2 red and black wires. At the back of the box there was a tie strap holding the wire in place, so I had to cut that. And then I had to flip this upside down and found there was some tape wrapped around this that was preventing me from removing the wires. So that forced me to take off this whole bottom. So there's 2 screws at the front I had to remove, and then there's 1 at the back. Remove that, and then this whole assembly can come out, and then I can get access to that tape. So I just cut through the tape with the needle nose and then peeled it back. And once I had that, then I could pull the wire assembly out. Before I installed it, I noticed an error. It was saying the hot end was 12 volts. And when I looked at the documentation, it was also showing 12 volts for the hot end. An Ender 3 is 24 volts. A CR10 is 12 volts. So I wondered if this was right. But then I could see inside the shroud, the fans were 24 volts. And then I measured the resistance of the hot end, and it was 13.2 ohms, which is a 24 volt hot end. So it was just the documentation was wrong. The parts were 24 volts. The first step was to connect the cooling fan, and you just screw it into place. Now I actually got these wires backwards. I'll fix that in a second. The next step was to put in the hot end. So I put the wiring for the hot end. These really shouldn't matter which way it goes, but it showed the positive to the right. And then the next step was to connect the thermistor, and then finally the filament cooling fan. And then, like I said, I got those fan connectors backwards, so I had to swap them. So double check your wiring before you power this guy up. So once I got that in place, then I just retape this with some electrical tape where I cut that tape before. So 2 strips of electrical tape wrapped around this seemed to hold it really well. So now I was ready to reassemble this thing. So I put a tie strap back to hold everything in place so I didn't pinch any wires as this assembly went back. And then I just lifted it back into place, making sure my fan wire was coming out to the top of it, and then lined up the holes and put the 2 screws at the front, and then I'll put the 2 screws at the back. I just hand tighten the front ones just partially, so then I can put the back one in, tighten the back one mostly, and then tighten the front too. So this thing shifted in place. I finally went back and tightened that back one as well. Once that was all in place, I flipped the machine back over and I reconnected my fan. Now I can put this cover back on. Remember, there's 2 screws in the front and 1 in the back, so I just put the 2 screws in front loose, did the back one, tightened that up, and then went back and tightened the 2 front ones. Now I needed to install this assembly, and I just did the same thing as I did before, slid it over the bar. It was already loose. The bottom wheel was already loose, so this popped in place, put the wrench in, and then just tighten the screw until this thing is tight. Then I needed to adjust that eccentric nut that it has until I got this flowing back and forth rather smoothly. Then I connected the belts on both sides, and then I just needed to tighten the belt, which I just did by feel to get this thing nice and tight. The kit includes an extension wire, a really nice extension wire, so you have to pull it off the stepper motor before and extend it out to the new stepper motor over here on the x-axis. So that's a nice addition that you don't have to build. And then I removed the old extruder and motor, and then I just strapped the wires to the holes where the extruder was before. And then I was ready to test it, so I heated it up, pushed some filament through the extruder. Everything seemed to be working. I leveled the bed and printed my first CHEP cube, and this thing came out awful. It was over extruding like crazy. I remembered in that old video where I installed that dual gear extruder that I just removed, I had adjusted the E-step. So I had to go back and do it again, mark 100 millimeters, and then control, motion, steps per millimeter, and adjust the E-steps. After running through it, 94.5 was the right value to change. And I reprinted the CHEP cube, much, much better. One of the advantages of direct drive is printing flexibles, and Ninja Flex is like a rubber band. It's really difficult to print on most Bowden setups. So printing this at 15 millimeters per second was a great test, and it came out fantastic. The results are really smooth. It's of course very flexible. I'm really happy with the results that this thing was able to do with Ninja Flex. In a previous video, I showed that you can put an EasyR extruder on your stock Ender 3 and print flexible material like Ninja Flex, but you have to print slower, 10 to 20 millimeters per second. So this allows you to print faster, and the quality is really quite good. Now, as far as printing PLA, I need to adjust my slicer settings because this is not nearly as good as what I was getting with the Bowden style setup. Now, I don't know if it's the extra weight of this thing because I'm really not seeing ringing, but it's just not as crisp as what I get with the Bowden style. And that's why I've always loved a Bowden style printer over a direct drive. The other advantage is it's easy to fix a clog on a Bowden style. I can pop that PTFE tube out and fix it. This one, if I get a clog, I got to take it apart. It's not quite as easy. So those are the major reasons why I stick with Bowden over direct drive, but I am liking this setup. And this kit from Banggood.com for $30 is an amazing deal. They sell out quick, so if you want to get one, I have a link in the description below. Grab it while you can. They get them in over and over, but they sell fast. And even this is on sale for $30. Normally they're on sale for like $35 every day. So it's still a good deal. And even if you have a hot end you're trying to replace, just the parts alone may be worth buying this setup. Now, if you don't even want to spend that, there are Thingiverse designs where you can 3D print a bracket and convert all your pieces from this guy into a direct drive. And a lot of people have done that, and it's been very successful. It's more work, but then it's, it's 3D printed. But I just think for $30, fully assembled, all I have to do is, reconnect some wires. This was great.
So there you have it. From 6 years ago, I showed you how to take a Bowden style Ender 3 and turn it into direct drive for flexible printing. I hope you enjoyed it. I want to give a big shout out to my present Patreon supporters. Many were with me 6 years ago as well. So thank you for the support. Thanks for watching. And here's a few other videos you might like. If you want to help support the channel, Patreon's the best way to do it. And if nothing else, click on that logo and subscribe. I'll see you next time right here at Chuck Hollenbach's Electronic Products and Filament Friday.